Now, in order to understand how to figure out what the order of a particular motion of the Rubik's Cube is, we're going to want to take that motion and write it in the tabular notation that we had done previously, and then we're going to want to put it into what's called disjoint cycle notation. So as opposed to that tabular form where we kept track of every single number and where every single number mapped, and in doing so we kept track of the order of the numbers 1 through 24 sequentially, which is a great way that makes sense for us, we're going to want to keep track of the numbers and where they map in a different order. We're going to want to start with a value that's moved by the motion of the cube, and we're going to want to say, well, where does this value map? And then the thing that is somewhat displaced by that original element, we're going to say, well, where do you map? And where do you map? And where do you map? And we're going to follow this sort of trail of breadcrumbs until we eventually get back to something filling that first empty spot. And then we're going to move on to the rest of the numbers in the cube. So I think this is best demonstrated with an example. So let's go back to this example for the motion F that we wrote down in tabular notation before. This is what I mean by tabular notation. We have a table here. Just as we did when we figured out how to fill in the numbers in that table, let's start with the front face and these numbers 1, 2, 3, 4 that we're seeing right here. We started by taking the 1 and said the 1 maps to the 2's spot. So let's see then where the 2 maps. The 2 maps to the 3's spot, the 3 maps to the 4's spot, and the 4 maps back to the first spot. And so what we'll do is we'll take them in a cycle. We're sort of thinking of a circle, but we want to write it as though we're writing on one line of paper. So we'll write it this way, 1, 2, 3, 4. And what we mean is the 1 maps to the 2's spot, the 2 maps to the 3's spot, the 3 maps to the 4 spot. And because we put these little circle reminders around everything, and we mean that the 4 maps back to the 1 spot. And then what we do is we proceed. And as we noticed before, the 5 and the 6, they're on the back face of the cube, and so they aren't mapped anywhere by moving just the front of the cube. So we could somewhat write that 5 maps to 5, like an open parentheses, 5, 5, and end the parentheses, but that just seems very redundant. And so the convention when writing things in disjoint cycle notation is if there is a value that is not moved by this particular motion, then we don't write it down. So we want to indicate that this keeps going, and there are other things that are moved by this motion, and so we put a little dot in between this cycle and the other cycle, and we put our parentheses to indicate that we're cycling. And now what we're going to do is we're going to pick something else that moves by this function. So if the 1 is moving, the 18 is attached to the 1, and the 18 is going to need to move too. And we can see that the 18 from our chart moves to the 7 spot. And then we ask, well, where does the 7 go? The 7 moves to the 24's spot. The 24 moves to the 13 spot. And lastly, that 13 spot moves to the 18 spot, back to where we began for this particular cycle. So we close the cycle and we move on. Now we've shown where the 1 maps and where the 18 maps, but we also need to account for the 8 and the fact that that maps somewhere. So if we do the same procedure with the 8, we find that the 8, we get the cycle 8, 21, 14, 19, and then the 19 maps back to the 8. And this is a list of all of the things that move in the order that they move in this cycle notation for that front rotation. Now, once we've taken a function and from its tabular form and written it in its disjoint cycle notation, something wonderful about that is we get the following fact, if you will. If we want to know the order of that motion, we look at it written in disjoint cycle notation, and the least common multiple of the lengths of the cycles that we have is the order of the motion. Now this is nice because we just wrote out this front permutation as a 4 cycle, so there's 4 things in it, a different 4 cycle, and a different 4 cycle. So according to this rule, we would say that the order of this particular motion of the Rubik's Cube should be the least common multiple of a 4 and a 4 and a 4, And it just so happens that 4 is the smallest possible multiple of those 3 values. Similarly, if we were going to take that R2U2 that we looked at and write it in its disjoint cycle notation, we would get a whole bunch of these 3 cycles. 1, 11, 9 goes back to 1, 2, 4, 12 goes back to 2. We would actually get 6 different 3 cycles, but it doesn't matter if I have 6 different 3 cycles. The least common multiple of 6 copies of 3 is still 3, and so this fact seems to verify our intuition and what we've seen so far for 2 different examples of motions of the cube.